Hi, in this episode I will show you the basic AI text-to-image generation workflow in ComfyUI. But before that, let's quickly look at how to install ComfyUI. When you navigate to the ComfyUI website and click the Download Local button, you will be presented with installation options for your operating system. I'm on Linux, so I only have the option to install from GitHub. If you are on another system, like Windows, you can also find a link to install a desktop app version. It's up to you how you want to install the tool, but if you have a bit of technical knowledge, I recommend installing it from GitHub. The installation process is described in detail on the GitHub project page, when you can also find tips for different GPUs and portable versions for various systems. I also recommend installing ComfyUI Manager, if it's not already included in your version. It's a very useful extension. Once you have ComfyUI downloaded and installed, you should see a clean user interface. We'll start with a basic text-to-image workflow, which is perfect for learning. You can find it in the left side menu under Templates. Select the Getting Started section and look for the image generation workflow. You can hold down the middle mouse button to move around the canvas and scroll to zoom in or out. The creators of this template added helpful instructions in boxes with brown headers. The first one, Model Link, tells to download the required model file from Hugging Face and place it in the checkpoint subfolder where ComfyUI is installed. That's because ComfyUI itself is just a tool for running models. The models must be downloaded separately. This particular model is about 2 GB in size and is based on Stable Diffusion 1.5, which is a few years old. You won't get highly realistic results with it, but it's perfect for learning how image generation works. It's also small enough to run on most hardware. In future videos, I will show more advanced and up-to-date models. After downloading the model, select it in the Load Checkpoint node. The red warning box should disappear once the model is loaded correctly. Blue rectangles are used to group and organize parts of the workflow. The rounded boxes are called nodes. A workflow is simply a set of connected nodes. Nodes have inputs and outputs, and connections between them are color-coded for clarity. In future videos, we will build workflows from scratch. For now, we will use this predefined one. The Load Checkpoint node is the core of the workflow. It loads the pre-trained AI model and provides three outputs. Model usually connects to the KSampler. Clip connects to the clip text encode nodes, where you enter prompts. VAE, Variational Autoencoder, converts between latent space and actual images. The VAE typically connects to the VAE decode node to produce the final image. We have two clip nodes. The top one defines what should appear in the image, positive prompt. Bottom one defines what should be avoided, negative prompt. The empty latent image node defines the image canvas. You can also start from an existing image by converting it into latent space, but here we will generate an image purely from text prompts. Be careful when changing width and height. Models are trained on specific resolutions, and large changes can produce artifacts. You can upscale image later using dedicated nodes. The KSampler is where the actual image generation happens. It takes the model, prompts, and noise, and iteratively refines the image. Here are the key parameters. Seed, the starting point of the noise. Using the same seed and settings will always produce the same image. Control after generate defines how the seed changes, random fix, increment, etc. Steps, number of denoising iterations. More steps usually improve detail, but take longer. CFG, classifier-free guidance. How closely the image follows your prompt. Sampler, the algorithm used for denoising. Denoise, how much noise is removed. For text to image, it should be set to 1.0. The output of the KSampler is still in latent space, so it must be decoded using the VAE decode node to get the final image. Let's run the workflow. The first run may take a bit longer because the model needs to be loaded into the GPU. The image is automatically saved with the prefix defined in the Save Image node. You can find generated images in the Assets panel or directly in the Output folder where ComfyUI is installed. ComfyUI also saves the entire workflow inside the image metadata. This means you can inspect all parameters used to generate the image, or drag and drop the image back into ComfyUI to recreate the workflow. Let's modify the prompt to generate different images. As you can see, the results are not highly realistic. That's expected. Stable Diffusion 1.5 is an older and relatively small model. Newer models produce much better results. In the next video, we will dive deeper into how Stable Diffusion works and how to use these parameters effectively. I hope you enjoyed.